Hi everybody. Today we're going to go through two different ways of calculating skewness. And in this case we're dealing with sample skewness. So let me put that in there. Sample skewness. There we go. Okay, so there's two different ways that we can calculate sample skewness. The first way, the hard way, is we're going to go through this formula. So just to go through the formula initially, we've got sample skewness is equal to n over n minus 1 times n minus 2 times the sum of xi minus x bar divided by s, quantity cubed. So what are these variables? Well, n is just the sample size. So whatever your sample size is, that's what n is. Xi, that's your individual x's in your sample. So this is x1, x2, x3, and so on down the line. X bar is the sample average. So if this is your sample, when you take the average of this, that's your x bar. And S is your sample standard deviation. I don't cover how to calculate standard deviation in this video, but you can refer to other videos that I have on how to calculate both the population and sample standard deviation. So let's get busy. Let's start creating these little pieces that we're going to need in order to make this calculation happen. So the first thing we need is x bar. I shouldn't say it's first. It's the first that I've decided to do. Okay, so x bar is just equal to the average of all of your x's. And so x bar is about 32.6. S is equal to the standard deviation. ST equals ST DEV, open parentheses, all of those values. And so we've got x bar, we've got our sample standard deviation, and so now what we need to do is subtract x bar from each one of our x's. So if this is x1, so we've got equals x1 minus x bar. But we don't want to stop there. First of all, we're always going to use x bar, so we want to lock x bar. And all we have to do to lock x bar on this column, as long as we're copying down, is to put a $sign in front of the 12. So now when we copy this down, every time we move down one space, B5 will move to B6, but B12 will stay the same. Okay, so we're going to put this in parentheses, and we're going to divide it by S, which is in, divided by S. And again, we're going to lock that location because eventually we're going to copy this down. Additionally, once we've divided by S, we want to raise this entire quantity to the third power. And so this is x1 minus x bar divided by S raised to the third power. So now when we copy this down, this will be x2 minus x bar divided by S raised to the third power. x3 minus x bar divided by S raised to the third power. Okay, so you can see where we're going. Each one of these represents xi minus x bar. In fact, xi minus x bar divided by S raised to the third power. Okay, so I'm going to bold that so you know that that's a title. It's not a formula. So that's this piece right here. So all we need to do to get this entire piece is to sum that column. Okay, and so we end up with minus 0.053674547. Big long decimal. A negative one at that. But we're not done yet. We need to multiply this whole thing by n over n minus 1 times n minus 2. And so N is 1, 2, 3, 4, 5, 6, 7. That means n minus 1 is 6, n minus 2 is 5. So that's the same as saying 7 divided by 6 times 5. Well, 6 times 5 is 30, and so we're just going to multiply this all by 7 divided by 30. Okay, so it's the sum of C5 to C11 times 7 over 30. So this is our skewness. Move the equal sign to the other side. So our sample skewness is minus 0.012524061 for these observations of x. Okay, so we just went through this entire formula to calculate skewness. Now here's the easy way. Equals SKEW. Highlight all of the values that you want to calculate skewness over, enter. Bang! You just got your skewness calculation without even having to go through much of anything other than a simple Excel formula. So I just wanted to show you how that worked and that the formula for sample skewness actually does work as promised. If you have any questions, drop me an email. Talk to you later, folks.